Hey lads, so here we're going to look at divisibility proofs using induction. Okay, so we have a question here. It says prove that 3 to the power of 2n minus 1 is divisible by 8 if n is an element of n. Well, all that's saying is if n is a natural number, and the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. Okay, so really what it's saying is if I put in a natural number in here and work it out, that the answer is going to be divisible by 8. Okay, divisible evenly by 8 now. So, just want us to get our head around this. So here we have our function, I call it. Okay? So I'm going to call it a function. And 3 to the power of 2n minus 1, is it divisible by 8? Well, you see, what they want us to prove is that it's divisible by 8 for any number whatsoever I put in there. Okay? So how do I prove that? Well, I could put in the first number, which would be 1. Okay? So let's try it for 1. If I put 1 in there, let's see if that's divisible by 1. So 2 ones are 2, so 3 to the power of 2 is 9 minus 1, which is 8. So it works for when I put 1 in there. Let's put 2 in there. 3 to the power of 2 minus 1. So 3 to the power of 4. So 3 to the power of 4 is 81 minus 1, which is 80, and that is also divisible by 8. I could try 3 in there, see is it divisible by 8? Probably will be, but definitely will be. Could try 4 in for n, see if it's divisible by 8. I could try any number I want. The only problem is, if I try a million numbers in here, and it all turns out to be divisible by 8. Okay, so if I try a million different numbers in here, and every one of them, it turns out, is divisible by 8, that's not proving anything. So let's say I put in, like I did, put in 1 for n, found out it's divisible by 8. Put in 2 for n, saw that it was divisible by 8. Put in 3 for n, saw that it was divisible by 8. Put in 4 for n, saw that it was divisible by 8. Did all the numbers up to 1 million, put 1 million in, saw that it was divisible by 8. After doing it 1 million times, I would be thinking, yeah, it's probably true for every number I put in there. But someone else could come along then and say, no. You've done the first million numbers, but does it work for the million and first number? And I could try that, and I say, yeah, it does work for the million and first number, and then they could come along again and say, but does it work for the million and second number? And then they could keep giving me numbers and numbers, and I'm never going to get to the last number. So just by subbing in numbers, I can't prove that every number that I put in here is divisible by 8. Okay? So here's how we approach that question. We presume that a number we put in there is divisible by 8. Okay, so we're going to presume that a number we put in there, okay, is divisible by 8. We're going to call that number k. The next number is going to be k plus 1. Okay? And if I can prove that the difference between these two numbers is a factor of 8, then I'll be after proving that every single number that I can put in here is divisible by 8. Okay? So we'll run over it again. I'm going to look at the second last number, I suppose. Okay? I don't know what number it is, but I'm going to just presume that it is divisible by 8. And now I'm going to see what the difference of these two numbers is. And if it is the difference a multiple of 8, then I know that's divisible by 8 also. Okay? So for instance, let's just say this was 800. Okay? I'm presuming it's divisible by 8. Okay? Which it is. Now if the difference between these two was 16, well, I'm presuming that's divisible by 8. I know this is divisible by 8, therefore this also has to be divisible by 8. Okay, so that's the way I'm approaching this question. So here's how we do it. So step 1, as always, prove for n is equal to 1. Okay, so I put 1 in there and I see if it's true. So I've done this already, but let's just see. So 3 squared is 9 minus 1, which equals to 8, and 8 is divisible by 8, so yes, it works for the first number. Step 2. Assume that it's true for n equals k. So we're going to assume that this works for any number I put in. And now I want to prove that it works for any next number, so any number after that. Okay? So prove true for n equals k plus 1. Alright? So here's how we set up this one. And again, this method I like, so the method they use in the book I think is a bit awkward, so don't look at the book, okay? Alright, so here we go. So looking back on this, okay, I want to see if the difference between those two numbers is divisible by 8. So here we go. F, so I'm calling it F because I'm just saying the function, okay, k plus 1 minus the function, okay. So basically when I put in k plus 1 and when I take away the k, that will be, and again we're going to look up at this and we're going to go 3 to k plus 1 minus 1. So that here is the k plus 1 bit, and then we're going to minus, and I'm going to put it in brackets just to keep it together, the way I don't get any of my signs wrong. And we have 3 2k minus 1. Okay, and a minus outside the bracket will change every sign inside, so just to tidy this up, we have 3 2k plus 1 minus 1 minus 3 2k plus 1, because minus for minus is plus. Okay, so to tidy this up a bit, we have 3, well I'm going to multiply out my bracket, so it'll be 2k and then 2 1s plus 2, minus 1 plus 1, they disappear, and then we have minus 3 to the 2k. Okay, let's keep going. I noticed there's a 2 here, so this is the same as 3 squared, okay, using the 2 multiplied by 3 2k minus another 3 2k. So that equals, well, 9 multiplied by 3 2k minus 3 2k. So think about this. We have 3 2k multiplied by 9. Right, so if I did 9 of them, 1 2 3 4 5 6 7 8 9. So that is basically 9 3 2k's. And then we minus another 2k, so one of them is gone. So we're going to have, be left with 8 3 2k's. Okay, so, well, that's telling me that the difference between the second last number and the last number is divisible by 8. How do we know it's divisible by 8? Because it's 3 2k multiplied by 8. So obviously this whole number has to be divisible by 8 if it's 3 2k multiplied by 8. And we could leave it at that, okay, but let's keep going with it. Okay, so we have, just going to bring this down here just to show exactly what's going on. So basically the last number minus the second last number is 8, 32k. If I add f of k to this side, I must add f of k to this side. Why am I doing that? I just want to get rid of this. So I'll be left with f k plus 1 equals 8, 32k. And well, what's f of k? Go back here, there. So plus 3, 2. Again, we put the k in instead of the n. Okay. So let's think for a minute. That is divisible by 8. Okay, we know it's divisible by 8 because we've assumed it up here. Actually, I definitely should have. 2k plus 1. Yeah, I should have just wrote that in. So 3, 2k minus 1. I've assumed that that is divisible by 8. Okay, so I've assumed that that is divisible by 8. So assumed divisible by 8. I know that's divisible by 8. I know because it's 3, 2k multiplied by 8. So that is divisible by 8. Okay, well, if I have two numbers and both are divisible by 8, then their sum must also be divisible by 8. For instance, 16 is divisible by 8 and 24 is divisible by 8. And if I add them together, I'm going to get 40, which is also divisible by 8. So if this is divisible by 8 and that is divisible by 8 and I add them together, then their sum will also be divisible by 8. Okay, so this number, which is this, must be divisible by 8 if both of its sums are divisible by 8. So I can therefore say, therefore, f k plus 1 is divisible by 8. So therefore 3, 2n minus 1 is divisible by 8 if n of n. So for all natural numbers. Okay. Hopefully, guys, that makes sense. Again, you're just following the same steps. Prove for n equals 1, assume for n equals k, and then prove for n equals k plus 1. Alright? Okay, any problems, let me know.